Okay, so I figured out what was going on when I got this answer, t is equal to negative 0.505. This is kind of a situation of the ambiguous case going on here. What that actually got me, it got me this point right here. So if I were to extend this, it would get me this intersection with the meters at 9 meters. It would be at this time. But we want this one. So both of these points are going to have the same sign value. And remember from our ambiguous case discussions, to get the other angle that has the same sign, so if we have two angles that have the same sign, for example, this angle right here is going to have the same sign as this angle right here. These two are going to have the same sign value because they have the same y value. How do we get it? We subtract it from 180. So our theta here, this angle plus this angle has to equal 180. So we take 180 and we subtract that theta. So that's what I've done right here. So the first answer that I got, theta could equal negative 0.253, or theta could equal pi minus negative 0.253. And when I do that, that gets me 3.39. Pi plus 0.253 gets me 3.39. Now multiply both sides of that. Sorry, I ran out of charge. I had to plop this together. 3.39 times 2 gets me 6.79. So moral of the story, the easier way to do this is just graph it on your graphing calculator. All right, moving on. Next problem, number 10. Another sine wave, it looks like we got here. Oh, cosine wave. Okay, let f of t equal a times cosine b of t minus c plus d. Part of the graph is given where when t is equal to 3, there is a maximum value at 29. Okay, so this maximum value right here is at t is 3, so my x value is 3, and my y value is 29. And there's a minimum, so that would be down here. The minimum is at t is 9, and the y value would be 15. Find the value of a, assuming that a is greater than 0. Okay, so what's my amplitude? All right, so what I want to figure out then, the amplitude is half of this range, half of the range. So I'm going to get my amplitude, I'm going to do 29 minus 15, because those are my y values, and divide it by 2. So 29 minus 15 is 14. 14 divided by 2 is equal to 7. So A is equal to 7. Find the period of this graph. All right, how long does it take to get from its maximum to its minimum? 9 minus 3 is equal to 6. So that means it's going to take another 6. Is this hours? We don't know. It's going to take another 6 units to get back up to the top again. So my period is going to be equal to 6 plus 6, which gives me 12. Okay, show that b is equal to pi over 6. Well, b is equal to 2 pi divided by the period. So 2 pi divided by the period is 12. If I reduce that, I get pi over 6. So I have now shown that b is equal to pi over 6. Find the value of d. d is halfway between the high and the low point, so I want the average of that. So it's going to be 29 plus 15 divided by 2. That'll get me my principal axis. So if I do that, I get 22. So d is equal to 22. Write down the value for c. Okay, so that's my horizontal shift. Since it's cosine, it starts at the top. How far has this been shifted over? It's been shifted over 3 units. So c is equal to 3. Now, what is the value of f of 18? So I'm going to plug that into my equation here. So I have 7 times cosine of, whoops, I forgot my b. My b is, where am I? b is pi over 6. Parentheses, t is 18, so that's what this is, minus c, c is 3, plus d, d is 22. And if I simplify that, I get 7 cosine pi over 6 times 15 plus 22. I can simplify this. 6 and 15, they can both be divided by 3. I get 2 and 5, so I get 7 cosine 5 pi over 2 plus 22. And I can actually do this without a calculator. If I think about 5 pi over 2, where would that be? So this would be 1/2, 2/2, 3/2, 4/2, 5/2. It would be right here. Okay, so if I'm counting around my unit circle to get 5/2 pi, 1/2 pi, 2 pi, 2/2, 3/2, 4/2, 5/2, it would be right here. And this is 0, 1, are the coordinates of that point, so therefore my cosine is 0. So this equals 0. So 7 times 0 plus 22 equals, running out of room here, equals 22. Right? So if this was a no calculator problem, I could do this. So what's f of 18? F of 18 is equal to 22. I can do that by using my unit circle. Right, that's it for that one. All right, the next one, the air temperature around a light bulb is given by the equation where x is the distance in millimeters from the surface of the light bulb. Background temperature in the room is a constant 25 degrees, and the temperature of the surface of the light bulb is 125. Okay, so that background temperature is a constant 25 degrees. So if I was to graph this, my temperature is never going to get below 25. So I'm going to have like an asymptote. And notice my equation here is a exponential. See, x is in the exponent, so it's an exponential. So it's going to go something, let's see, it's going to start hot, and the farther I get away from the surface, it's going to come down. So it's going to do something like this. It's never going to get below 25. So that's my horizontal asymptote. That's going to be my A. Okay, so if I can start filling this in, the temperature is going to be equal to 25. It's never going to get below that. The starting temperature, B, if this number right here is the starting temperature. So what does it start at? The background temperature is 25, the surface of the light bulb. Okay, so the surface is going to be 125. 125, that's my starting value. It doesn't get any hotter than that. And then I have 2 raised to the negative x over k. All right, so we need to find the values of A, B, and K. Oh, we already found A and B. Okay, so A is equal to 25, B is equal to 125. Now I need to figure out what K is. So I'm going to use this information. 3 millimeters, that's my X, and the temperature of the light bulb, that's my T. So I'm going to put those in. T is 75, is equal to 25 plus 125 times 2 to the negative 3 over k. And then I can simplify this. I'm going to minus 25 from both sides. I get 50 is equal to 125 times 2 to the negative 3 over k. I'm going to divide both sides by 125. So I get 50 over 125 is equal to 2 to the negative 3 over k. Now, when I have a variable in the exponent, I like to rewrite it as a logarithm. Oh, I can also simplify this. 25 goes into both of those 2/5. Okay, divide 50 and 125 by 25. I get 2/5. So now that means I can rewrite, let me put it back over here. 2/5 is equal to 2 to the negative 3 over k. I'm going to write this as a logarithm. So I'm going to have log, my base is 2, my value is 2/5, and it equals my exponent, which is negative 3 over k. Okay, to get k out from under here, I'm going to multiply both sides by k. Oh, here I go, running out of room again. And then to get k by itself, I'm going to divide both sides by log base 2 of 2/5. So I'm just going to go ahead and do this. I get negative 3 divided by log base 2 of 2/5. All right, this I cannot do without a calculator. So I'm now going to put that into my calculator. I have charging over here. So in order to do this, I'm going to have negative 3 divided by, and I'm going to put this into parentheses. I'm kind of zoomed out. Let's zoom in a little bit more. Divided by log. To change the base here, I have to go math alpha math, and that gets me, okay, I went math alpha math. That gets me the change of base. This should be in your notes somewhere. 2 divided by 5. And close my parentheses. Okay, let's see if that works. Yay, it worked. Didn't give me an error. All right, so K is equal to approximately, I'm going to have to round that off, approximately 2.27. And there it is. There's my K. Wow, that's a complicated problem. Okie dokie. Next problem. Write an equivalent. Oh, so here's some nice easy logs. That's good. I should have done these before I did that hard log problem. Write this as a logarithmic equation. So it's going to be log. What's my base? My base is 2. What's my value? My value is 1/16 is equal to the exponent. The exponent's -4. That's how we write that as a log. Okay, write this in exponential form. So that's, my base is 9, my exponent is 3/2, and my value is 27. Okay, so just reminding ourselves how to rewrite logarithms. All right, evaluate. So 9 to some exponent is equal to 81. Okay, I can set that equal to x. 9 to what exponent equals 81? Okay, that one I can just do by inspection. That's just 2. 9 squared is 81. I don't need to work too hard on that. Okay, if it doesn't give me a base, the invisible base then is 10. So this is 10 to some exponent is equal to 1,000. Okay, so again, I can just do this by inspection. There's 3 zeros, so I know that x is 3. So log base 10 of 1,000 is just equal to 3. Just a little out of focus. Let me focus in on this. Sorry about that. All right, next one. Okay, x cubed, x to the 6. I have no idea how to do this. So this is where we're going to use some substitution. I'm going to let u equal x cubed. So that means this first one is 2u squared plus 7u equals 15. And now I can solve this as a quadratic. So this is 2u squared plus 7u minus 15 equals 0. And I can factorize this. Okay, so what am I saying? To get x to the 6, how did I get u squared? I would need to square this. U squared would be equal to x cubed squared. 3 times 2 is 6. Okay, so that's why I was able to replace the x to the 6 with u squared. And now I can factorize this. To get 2u, that's going to be 2u times u. And then 15, it's going to be a 5 and a 3. And I need more positives than negatives, so I'm going to make this one positive and this one negative, because this gives me 10 minus 3 is 7. Then I can set each of these equal to 0. And if I solve this one first, add my 3, divide by 2, and this one minus my 5, and then substitute back in my x cubed. So u is the same as x cubed. And here again, u is the same as x cubed. And then I'm going to take the cubed root. Okay, so I am just going to take the third root of each of these. And if I'm doing it without a calculator, I get this is equal to the third root of 3 over 2. And in order for it to be a positive, there's only one answer. It can't be plus or minus on this one. It's just going to be a positive. Sorry, I need my little 3 there. Another way of writing that is 3/2 to the 1/3. It's the other way of writing that. And no plus or minus, because if you were to cube a negative, you still end up with a negative. Okay, so on this one, again, I'm going to take the cubed root, and for this one to be negative, the whole thing needs to be negative. So it's going to be the cubed root of 5, which would, running out of room again, why do I keep doing this? So another way of writing that one would be, I'll put it next to this one, negative 5 to the 1/3. Okay, so there's 2 answers there, 1 and 2. So that's using substitution. Okay, so this one I can also solve using substitution. I'm going to let u equal log base 4 of x. So this is going to be u is equal to, okay, what have I got here? I'm going to use my power rule. I'm going to bring my 2 down front. 2 times log base 4 of x, the whole thing squared. So log 4 of x, I'm going to change that also to u, so I get u is equal to 2u, the whole thing squared. And if I square that, I get 4u squared is equal to u. Again, it's going to be a quadratic, so I want to set it equal to 0. So I'm going to get, how should I do this? 4u squared minus u. I'm going to minus the u equals 0. And then I can factorize that. And then I can set each of these equal to 0. So u equals 0, or 4u minus 1 equals 0. And I can put back in my log. U is log base 4 of x is equal to 0. So I get 4 to, if I change that to exponential form, I get 4 to the 0 is equal to x. So x is equal to 1. And I'm running out of room. So there's one answer. X is equal to 1. And the other one, oh, I think when I published my answer key, I said there was only one answer. But that was wrong. Huh. Very strange. What did I do? Okay, so anyway, the next one, this one, add 1 to both sides, so I get 4u is equal to 0. Divide both sides by, oh, what am I doing? Add 1 to both sides. 0 plus 1 is 1, sorry. Add 1 to both sides. And then divide by 4, so I get u is equal to 1/4. And now let's substitute back in my log. Here I go, running out of room again. Log base 4 of x is equal to 1/4. So that would be 4 to the 1/4 is equal to x. And that would be the 4th root of 4. So I would just leave it like that. Okay, and apparently when I published these before, I published the wrong answer because I'm just looking at my answer key and I had something completely different. What was I thinking? Right, so here it is, that one and that one. So x could equal 1 or x could equal 4 to the 1/4. Okay, now this one I actually kind of want to check this because when I did this before I got a different answer. So let's see, if I go back and I check this, let's see what happens. So if I do math alpha math base 4 and I'm saying x was equal to 1, what do I get? That's 0. Okay, let's see if the other one is 0. So I'm going to have math alpha math base 4 of 1 and get that, and then I square it, get that, and then I square it again. Yeah, okay, that works. All right, so that one checks. Okay, let's check the other one. To the 4th root of 4. So I'm going to have log, oops, I need to do log base 4 of, what did I say x was? Of 4 raised to the 1 divided by 4. Okay. Okay, that would be that. What do I get? I get 0.25. Let's see if the other one gives me 0.25. See if that one works. So here I get math alpha math base 4 of 4 raised to the 1 divided by 4. And that's squared and then squared again. Okay, that one didn't work. So something went wrong. Oh, and I hate it when I do this. I hate it when I make mistakes when I'm live. And that's not the answer that I got before. So what did I do wrong? All right, taking another break. Don't you love it? Your teacher makes so many mistakes.